Okay, this is Unit 11, video number 2, and this we're talking about geometric sequence and series, and we will do some Regents questions at the conclusion of this discussion. This is a geometric sequence. It goes up or down by the same ratio each time, and by that I mean a multiplier. So if you look at the first example, 4, 20, 100, 500, 2500, each time we're multiplying by 5. So 4 times 5 is 20, 20 times 5 is 100, 100 times 5 is 500. 500 times 5 is 2500, so that would be our common ratio. If you look at example 2, it's negative 2, negative 1, negative 0.5, negative 0.25, negative 0.125. In each case, our common ratio would be that we are multiplying by 1/2 or 0.5. We don't say what we're dividing by. We say what we're multiplying by to go from one to the next. Now, if this multiplier changes, this would not be considered to be a geometric sequence. It may be considered arithmetic from video number 1, or it may be considered neither one of these. If you look at our third one, our numerator is the same, but our denominator changes each time. So we would have 2, and then negative 2/3, and then positive 2/9, and negative 2/27, and then positive 2/81. Now, at first, you may not notice that you are multiplying by the same number each time because it goes negative, positive, negative, positive. But if you notice that alternating pattern, you are probably multiplying by a negative number because a positive times a negative is a negative, but then a negative times a negative will give us a positive. And if you notice that only the bottom is changing, then you are probably multiplying by a fraction where the numerator is 1. Okay, so in this example, our common ratio would be negative 1/3. So there is a way to find the formula for the geometric sequence, and this formula is a sub n equals a to the first times r to the n minus 1. And this formula is not given on the Regents exam. You are expected to know it, so I'm going to highlight it so you can go back and find it if need be. And so here's how you use it. If we use our second example right here, our start number is negative 2. Our common ratio would be 1/2. You could use 0.5, that's fine. And we would raise it to the n minus 1 power. So that would be the generic formula. And if suppose you want to find the eighth term, you would just plug in 8. So you get negative 2 times 1/2 to the 8 minus 1 power, which is plugging, when you do 8 minus 1, you get 7. So negative 2 times 1 over 1/28, that is the 7th power of 1/2. And if you just do your multiplying, you get negative 2 over 1/28, which simplifies to negative 1 over 64. Or you could just use a calculator from the get-go and go straight from here to here. That's fine. It's a multiple choice question, of course. That's the quick and easy way. If you would like to demonstrate your work, go a few extra miles and do the rest of it. Moving on, a series looks like a sequence. I didn't mention this in the last video, but it's important to note that a series looks like a sequence, except instead of commas, it has plus and or minus signs in it. So here I gave you one with both. So this is alternating. We have 4, negative 8, positive 16, negative 32, plus 64, minus 128, plus 256. So this would have a common ratio of negative 2 each time. And then you would recognize that it's geometric. And your ratio would be negative 2. But this is a series and not a sequence because it has addition, subtraction, and not commas. So here's the formula for the sum of a finite geometric series, right from the formula sheet. And so to find the sum of the first 8 terms, you would use the sum formula. So I just copied and pasted it over here, and now I've plugged in the 8. Our first term in our example is negative 2. And this is 1 minus 1/2 to the 8th power over 1 minus 1/2. So long story short, this is a typo. This is supposed to be 256, which is going to change the outcome of my problem. When you do this, you're going to be very careful and use a calculator, otherwise you will make mistakes like me. And so what I did was say 1 minus 1 over 256, so I got a common denominator of 256, and subtracted 1, so I get 255, multiplied by negative 2. It's just going to give me a minute to clean this up. So we have negative 2 times this, so we're going to have negative 255 and then divide that by, when I simplify it, it'll give us a 128. We divide that by 1/2, which is the same as multiplying by 2. So we get negative 255 divided by 256. And this is our final answer here. Okay, so again, this can all be done with a calculator. You can go straight from here, the first step, to the last step if you would like, or you can show some of the work along the way. The important thing is that you notice what each thing stands for. A1 is your first term, which was -2. R is your common ratio, and N was the term number. Okay, moving on to a couple of Regents questions. Here is the sequences off the packet that I handed out in class. And so what is the formula for the nth term of the sequence B shown below? Now notice we know it's a sequence because it has comma. And we're going to use that formula that I gave you in the first video. This is a +2 each time. So if you notice you're adding 2 each time, that's what we're doing. So this means we have a common difference of 2. So we are going to be dealing with an arithmetic sequence. It says identify. So this is arithmetic. And our formula then is going to be B sub n, using the letter of the problem, equals A1, or B1 in this case, which is 10, plus n minus 1, times our common difference, which is 2. And then we just have to do some simplification, which would be 10, and then doing the distributive property, we have 2n minus 2. So far, that still doesn't look like anything. So if we combine like terms, we get 8 plus 2n, which is our very first choice. Okay. If you look at the next thing, this is a pretty tricky way to do this. It says A1 is 4, A2 is 10. Oops, I didn't mean to underline. Sorry, guys. A3 is 25, and A4 is 62.5, which represents the nth term. So they didn't give it to you with commas, but it's pretty clear that you're going to plug into a similar formula. I'll leave you to do that on your own. And this is what's the formula of this sequence. Now, if you notice, you're dividing by 3 each time. So that means you're multiplying by 1/3. That means that is your R. Your initial value is 54, so that's going to be your start number. That goes out in front. And then your common ratio, which is 1/3, to the n minus 1. Now notice on these Regents questions, they don't give you any indication of anything other than you actually are going to have to memorize these. So that's the end of the first page. Determining the common difference. This page is just very simply deciding what is the common difference. In this case, we're adding 3 each time, so the common difference is 3. It's always what do you do to the first term to get to the second term. That's your common difference. And so you can go through and check these out on your own. The answers should be on the back of your pages. And I just want to give you another chance to look in case these questions were not given in the packet. Here's 31. What is the common ratio? So that's the number that you are multiplying by each time. If we look at number 2, for example, the top is being multiplied by -3, and the bottom is being multiplied by 2. So that's going to be -3/2. And you can take a look at these on your own and check your answers. These next things are sequences. Determine the common ratio in a geometric sequence. Again, this is just a little bit different. What is the 15th term of the sequence? Now, you can continue the pattern. So you're more than welcome to just continue the pattern out until you get to the 15th term. They usually give you the first 5. Or you can use the formula that we've discussed previously to calculate the 15th term like I showed you earlier in the video. So those are just 2 questions. And this is a recursive sequence. I'm actually going to cover recursive sequences in class. I don't think I gave these to you in your packet, in case you're wondering what happened to 33. We are going to talk about recursive sequences in class on Tuesday the 7th. Sigma notation. This is the very first thing I gave you in Unit 1 video. you're just going to plug in, this is the start number, this is the stop number, and you're going to plug them in one at a time, then add it up. So this would be 2 squared minus 1, which overall this gives us a 3. And this is a slightly different way that I'm expressing it. You could do it horizontally or vertically. I'm showing you vertically at this time, and this would give you 8. 4 squared minus 1 gives us 15. And then we stop with 5 squared minus 1. And that gives us 24. We add them up. You get 3. So then you want to make sure that if this is not multiple choice, you're clear that you're adding. So 3 plus 8 is 11. 11 plus 15 is 26. And 26 plus 24 gives us a grand total of 50, which is choice 4. Okay, sometimes I like to do it this way so then you can have intermediate answers and get partial credit, but you could do it either way, like I showed you in the first video, or like this. And if you notice, this is a pretty common question on the Regents exam. Scrolling down, just in case you don't have your packet and you want to give some of these a try, you can feel free to pause the video at any time to try some of these. Here is more using a going backwards and coming up with the formula. So this time you are adding 2 each time, so you could see that. Your starting term, you start with a 5. That doesn't mean that that is the number down here. This just means that this is your A1 equals 5, and your D is 2. And so you're going to need to come up with a formula and then figure out which one of these lines up with your formula. Okay, as you go through, this is probably the more tricky one, so take your time and check your answers on these questions. Here's some more Regents questions with this sigma notation. Being careful that you recognize that this is a little more tricky, and see what you're doing each and every time. Which of these is not correct, so you have to be careful when you answer these questions. Again, these are popular questions, and these can be a little bit tricky, so take your time to go through them. And when we get back to class, make sure you ask about anything you don't understand. Here are the sequences, and here's the sum. So this is using the sum formula that's given on the formula sheet, or you can actually just add them up. So again, this is just plugging in and going through. Some of these use the formula. Oh, maybe not these. The next page does. But these will allow you to just plug in and add up. And here are the ones that actually use the formula. Here we could see that we're that each time you're multiplying by -4, so that's going to be your R. And you know your first term is 3, so that's A1. And you can either keep going, which I suggest might be easy with a calculator, but remember that you need to find A8 somehow. If this is a common difference, you're going to need to find A8. If this is a common ratio, you don't need to find A8. And so I'm going to leave it up to you to decide if it's arithmetic or geometric, and decide which formula to use to plug in. Okay, I'm going to cut this off here. We're almost at 15 minutes, which is a really long video for a math video. And I will cover all these in class next week.